Hey guys, I want to continue with discount rate just because it's such an important concept in environmental economics, and especially in the context of climate change. So did you do those calculations? Have a look at those tables that I showed before and look at your own solutions to that net present value example with the 10% discount rate. So I had net benefits discounted. So what I've done here is I just added all those discounted net benefits up, and they're negative in the beginning, which says that, what does that say? That the costs are higher than the benefits. You add them all up, you get the same number as what we had in the table, minus 121. If we have this negative net present value, should the project go ahead or not? What does that mean, a negative present value? If you don't understand, then go back to the previous bit of the lecture and review. Now what happens if we use a lower discount rate? For example, 3%. I've done exactly the same. I've discounted, we have the same benefits, the same cost, but I've discounted them at a lower rate. Now what you see now is that the present value of the benefits is actually higher than the present value of the cost. Why is that? Well, because we don't discount these large benefits in the future as much. So overall, there's a net benefit over time, and at this discount rate of 3%, we should undertake the policy. So putting a higher value on future impacts results in different decisions. And this is particularly important in the case of climate change. I'm going to show you two graphs that are from a very famous Australian-based climate change review called the Garnaut Report. So this is Professor Garnaut, who looked at the cost and benefits of climate change and taking action. So let us interpret this graph, which is a good exercise, I think. Let's look at their utility functions or utility graphs, which means the welfare that people derive. This is the current situation, and the orange line is our welfare, our utility, if we don't take climate change mitigation action. That shows that, okay, in the beginning we may get richer and richer and we may be better and better off, but over time, climate change impacts will affect our utility, will affect our welfare, and our welfare will start to level off. Sometime in the future. We don't know when, but it will happen. Now let's look at the blue line. The blue line is the line of utility when we have taken mitigation actions. In the beginning, those mitigation costs will be quite high and therefore reduce our utility. That's why the blue line is below the orange line in the beginning. The costs are higher than the benefits. But over time, because we avoid climate change, we can reap the benefits of those mitigation actions, and our utility might go up and up. And at some time in the future, we don't know exactly when, we have this utility crossover, where the avoided climate change impacts are greater than the mitigation costs. Now, why is it so important that we choose a correct discount rate? What happens if we place more value on future damages? Also, what happens if we consider more negative impacts of climate change? Well, what will happen is that this future utility will actually go down if we include more impacts, because there's more damage. And if there's more damage, the benefits of mitigation outweigh the cost at an earlier point in time. So it becomes more worthwhile to take action. And the same occurs if you have a lower discount rate. If you put a higher value on those future impacts. If you care a lot about future impacts, your utility will go down because you care about the negative impacts, and you're more likely to undertake action. It's a complex discussion that we still haven't solved. What we typically do is we use a range of discount rates and do a bit of a sensitivity analysis as to when does that crossover point occur at different discount rates. So there's a couple of challenges involved in cost-benefit analysis and climate change. The benefits might be difficult to measure. Those non-market benefits are hard to grasp, and sometimes the benefits are uncertain because climate change is uncertain. Another challenge is that the cost will definitely be incurred and are very soon. But the benefits that come from reduced climate change impacts are later and are also uncertain. Then we have this whole discount rate debate. So you might come across other arguments that people can adapt to climate change and therefore the cost of climate change impacts are not as high. You could also come across the argument that we use a discount rate that's too low. There's too much weight put on future generations. That could be very much a personal choice, which I'll just leave with you to think about. You'll discuss this issue more in the tutorial and you'll practice with benefit cost analysis. What I want you to take away from this lecture is a bit more insight about this whole debate about climate science and whether we take action or not. And I want you to understand benefit cost analysis. I want you to understand that we compare the discounted net benefits with the discounted net cost. So make sure that you practice those because they will come back in the exam. Thanks, guys.